Some people say constraint programming is the holy grail of programming. The user just describes his problem in terms of variables, constraints, and possibly an objective function to minimize. Then the solver will find a solution for you. This is almost magical. Let me illustrate this with a job shop scheduling problem. A bunch of activities must be scheduled on different machines. Every machine can execute only one activity at a time. Also, some precedence constraints must hold between the activities. The objective is then to schedule all the activities such that the overall duration of the schedule is minimized. This problem is very complex to solve, especially if you want to solve it with a dedicated algorithm. With constraint programming, you can describe it at a high level. You just have to introduce some variables to represent the start time of the activities, some precedence constraints, and the resource constraints. And that's it. The solver will find a solution for you. What is really nice with constraint programming is that you have a very expressive language to describe your problem. You can really compare it with playing Lego. Every type of brick corresponds to a different type of constraint that you can reuse in many different problems. But how does this work? First, the user introduces some variables. Every variable has a set of possible values. We call it its domain. Then there is also the constraints in your model. A constraint is actually an algorithm in charge of removing impossible values. Let me illustrate this with a constraint that Sudoku players are very familiar with. The all different constraint. Every variable must take a different value. As you can see, some deductions can be made to remove impossible values. Then to find a solution, the solver will explore a search tree, but it won't try every possible combinations of the domains. That would be too inefficient. Instead, the solver will prune the search tree by letting the constraints remove impossible values. As soon as a domain becomes empty, it means that there is no solution and the solver can backtrack. In my research group, we develop a constraint programming solver called OscaR. We do research to improve the efficiency of OscaR. If you like algorithm, you will for sure love this line of research. We also try to improve the user experience at modeling problems. For instance, we currently investigate how to make the computation distributed over hundreds of processors such that it's very fast to solve and almost transparent to the user. We also use OscaR to solve challenging problems. One of the cool problems we recently worked on is traffic engineering. As you know, the internet is a large connected network. But as it is the case for vehicles, there can be some congestion on the links because the capacity is limited. The traffic engineering problem is then to decide for every traffic demand what should be the path to follow such that everything runs smoothly. We tackled very efficiently this problem using OscaR and constraint programming. If you want to know more about constraint programming and OscaR technology, feel free to click on the link below.